So in the previous video, we talked about running a test to test a claim, and we looked at the null and the alternative, how to write the null alternative. That should be your starting point for each one. Read the problem and decide what is actually being tested, what values are we looking at, and are we going, and what the sample that we're looking at that we're going to compare to the null value that we think is the status quo. Remember, the null is where we start at. That is if things are staying the same. The alternative is the change that we think. Is it not equal to, greater than, less than, increasing, decreasing? And now we're going to be looking at the procedure to actually judge which one, or do we feel like the null is true, the null is false, alternative is true, alternative is false. Right? So we're going to focus on testing a mean. So we're going to be using the mu symbol and the calculations for the critical value and the test statistic are going to be based on the mean procedure. So we will go over proportion later. Right now it's just the mean. So here's the condition, or at least one of the main conditions for testing this. And the sample must have a normal distribution or have a sample greater than 30. There are some other things about randomness and things like that that we would have to check as well. This is one that I'm going to point out, and I'm going to say again, in this class from now on, every condition is going to be considered satisfied. Okay, so every test we run is going to be a valid test. So even if it doesn't say it's normally distributed, let's assume that it's normally distributed. We assume randomness and all the experiments are done correctly. Okay? Now, when we're testing a mean, okay, your first step is always to find your null and alternative hypothesis. And the next thing you need to do is to decide, are we using the critical value method or the p-value method? Okay, so for this class, I'm going to tell you which method to use. Technically, the two methods are connected. Okay, you can't get a p-value without your test statistic. You use the test statistic in the critical value method. Okay, all those things are taken into account when you're doing either one of those methods. I'm separating them, so sometimes you're going to have to do the calculations by hand with the formula. Other times you're going to be able to use the calculator function just to quickly get some of the values to make your conclusion. Okay, so today we're going to be looking at the critical value area method. Okay, so if it says use the critical value method, this is what you're going to be doing. Okay, so let's picture we're reading the problem, we write down our null and our alternative. Okay, your next step, okay, is to find a critical value and label. We're then calculate the test score, and then you compare and analyze. Okay, so we're just going to go through the procedures. We're not going to do an example. That'll be in the next video. We're just going to go through the procedure. So we have our null and alternative. Now we're going to find our critical value. Okay, for the critical value, we have to determine what type of normal curve we're looking at. Okay, and you're going to look at the alternative hypothesis. So again, you need to have your null alternative first, because that's going to be, you're going to use that alternative to base what your curve is going to look like. Now, what I mean by that, okay, we're going to have either less than, you're going to have greater than, or you're going to have not equal to. For each one of these curves, now it says, look at the alternative hypothesis to see where the shaded area is. The shaded area, I'm going to consider that the reject area. Okay, and I'll explain a little more about that in a little bit. So if it's less than, we are always on basis off of the normal curve, which we looked at before previous in this class. And if it is less than, that means we're going to have a one-tail, left-tail test. And our critical value is going to be at that point there. And I'm going to put a negative sign because it's a negative critical value. Now, what I mean by the shaded area is the tail end is considered our shaded area. And if our test stat, when we calculate it, falls in that area, we are going to reject the null. Okay? Reject the null means that there's evidence to say the alternative is true. If it falls in the big area, we say we fail to reject. Okay? So we have either reject the null or we fail to reject the null. Think about what that means. Fail to reject. If you fail to reject, that means you're saying there's no evidence to say we should not believe this. We're going to believe that the status quo stayed the same and the null is the correct answer for this one. So less than is on the left tail. Greater than is going to be your right tail, and my shading is going to be the same, it's just the opposite direction. There's our shaded area, and we have reject and fail to reject. And for not equal to, okay, so we have not equal to, that's going to be a two-tail test. Shade in those. Again, it's the tails that is considered the shaded region. And we're going to have two reject areas. Reject. Reject. Fail to reject. Okay. So these curves are very important because that's what we're going to be, that's part of judging if we're going to believe the null or if we're going to believe the alternative with the evidence that we have. Now, how we get that critical value, okay, I put the critical value over here, let me fix that. Negative critical value there, okay. The way we're going to judge that is using our T-chart that I gave you. Okay, find the critical value using the T-chart and degrees of freedom. Degrees of freedom is n minus 1. Okay, so whatever our sample size is, minus 1, okay, you're going to need that, and we're going to need to be able to judge one tail, two tail. Okay, that's the important pieces here. And just like the other thing we're going to need is our alpha level. Okay, our alpha level is based off of our confidence level. So just like for confidence intervals, we are either 99, 95% confident, same thing's gonna happen for here. The alpha level is the complement, okay? So we're gonna base that off of the complement. So if I say you are 99% confident, our alpha level 0.01. 95% confident, 0.05. Okay, so that's what we're basing that off of. And if you look at the chart, if you look up top, that has our alpha levels there. So let's take a look at it. So from here, degrees of freedom is n minus 1. We're going to need our alpha level, and make sure you're paying attention to one tail and two tail. Okay, here's the chart, and you can see the important things here are judging. I had two sections here. Now, I like this chart. It's a little older, but I like it because it splits it up into two tails and one tail. That takes an extra step away from us, which I like. Okay, so based off that, you need to say, okay, let's say I have a one tail test. That means I'm looking over here. Degrees of freedom is going down the side. So again, degrees of freedom is n minus 1. Okay, and then we have our alpha levels. So even if you want to, you can write, okay, this alpha level is 95%. 99% and 99.9%. If you want to put that on your chart, not a horrible idea. So now that you know it's straight, because it's not usually for critical value method, it's going to say be 99% confident, be 95% confident. Well, now I know which column I'm looking at for there, okay? And what you do is you would just look at it, one tail, let's say our degrees of freedom is 9, 99%, 2.821 would be our critical value. Okay, so this is the chart we're using for our critical value. So now we have our null and alternative. We have our normal curve drawn with the critical value labeled underneath. So now that critical value is there, we can tell, okay, if it lands on one side, we reject the null. If it lands on the other side, we fail to reject the null. To judge what's going to fall, where it falls, we need to find our test score, okay? Our test score is going to be the sample mean minus population mean, the mu, divided by sample standard deviation, divided by the square root of n. It's not horrible. I don't have it on here. Maybe put some parentheses, okay, around those 2 points. Okay, now what we're gonna have, okay, you're gonna have your data set, you're gonna need to use that to find your sample mean, sample standard deviation, your sample size. Okay, that's all from the sample. The mu, that's what's in your null and alternative. That's what we think is being tested. That's the claim that's being tested. Okay, so X bar, S, and N is from the sample. Mu is from the problem, from the what we're looking at to be tested. Okay, so you would calculate your test statistic and then you go back to your curve and look where it falls. Okay, the normal curve is just like a number line. So you just look, is it greater than, is it less than, determine what area it's going to fall in. And once you have that, then you can come up with your conclusion. Okay, and our conclusion is either rejecting the null, which means we have evidence to support the alternative, or if we fail to reject the null, which means we support the null. Now, be careful with this one. This is very, very loose that I'm having on here. I'm very, very much simplifying this. When we're doing hypothesis testing, we're finding evidence to support our alternative. So you really shouldn't ever say we support the null. There's just no evidence against the null, and that's why we say fail to reject. Okay? But this is just kind of simplifying it a little bit, where in this class, for us, rejecting the null means we side with the alternative. Fail to reject the null, we side with the null. Okay? So that's the procedure. The next video is I'll show you examples, the calculations you're going to need to do, and I'm going to work through using the chart and everything else to find those numbers.